Hello and welcome to this BricsCAD Digital Summit breakout session for BricsCAD Mechanical. My name is Fredrik Gundersen. I act as a product owner within BricsCAD, and today I will be taking you through this session about sheet metal designs and preparing designs for manufacturing. So let's get right into it. The goal of sheet metal designs is to create them efficiently, meaning that the design process itself is efficient, that the design is easily translating its intent, and as a result also efficiently translates the manufacturing information to be able to manufacture the parts. First off, there are also many benefits to sheet metal designs. They are both strong and malleable at the same time. Compared to other materials, especially, sheet metal can be strong and durable, while it's still possible to shape it into very specific shapes. The materials often used are, for example, stainless steel or aluminum. They are also resistant to pressure, corrosion, and cracking. These points are especially true if we compare them to that of a part that is cast, where you would need an expensive mold to begin with to create a part, and then the finished part is still susceptible to the problems I mentioned earlier. So in addition to these benefits, this also allows the sheet metal parts to be easily replaceable, sustainable, and cost-effective as well. Therefore, with this in mind, it is obvious that sheet metal designs are highly desired for a design purpose and manufacturing method. And as a result, these designs are wanted to be modeled within a CAD environment, so that one can get the benefits of CAD as well through the design process. However, this is where some of the problems start. There are a lot of considerations to keep in mind when designing sheet metal parts. These considerations are also important for how the part is manufactured. And if some of these things are not considered, there is no guarantee that the design can be actually manufactured. Some of these considerations can be the wall thickness of the parts, that they contain a consistent wall thickness throughout the parts. The bend radius also is reflected and in relation to the thickness of the walls accurate. The K factor also is a consideration to have and an input to give accurate unfoldings. Certain things such as bend reliefs, which essentially are small details necessary for making the part manufacturable in an effective way, need to be modeled as well. So as a result, in most cases, sheet metal designs are the easiest to make in CAD when not considering these manufacturing limitations or information. One could even say that CAD systems are not involved in the manufacturing process, but rather a CAD/CAM system takes this role. Therefore, manufacturers can suffer from a lack of communication between these steps, where the manufacturing process might not even have enough information to complete the part or to make it accurate to the design. This is why BricsCAD Mechanical gives you the complete workflow, from design inception to preparing for fabrication. And it even helps you through the painful steps of design considerations. Our sheet metal tools help to automatically detail your designs with manufacturing specific information and form features, such as bend reliefs and relationships between bends and junctions and the reliefs in between. Meaning that BricsCAD Mechanical allows you to easily create and supply fully manufacturable designs in CAD that can immediately be sent to production, certain that it can actually be made. Currently, we have this model which was prepared in another breakout session, the session for 3D modeling with BricsCAD Pro. As one of the problems we discussed earlier, this model is designed to represent the final design, but without any manufacturing considerations. So with the sheet metal toolset in BricsCAD Mechanical, we will detail this design. ensuring that it can be unfolded and as a result manufactured. We can start by converting the parts to sheet metal. This will automatically detect thin-walled solids and classify them as flanges in the sheet metal context. However, these flanges are still connected by hard edges, so we need to define the purpose of the edges and how they will behave. First, we can apply bends. Now, the flanges connected to this bend will unfold along it. We can also see that in the process of creating bends, some junctions are automatically created. These junctions are where the flanges will split apart during the unfolding process. We can still also define more needed junctions. As you can see, we can easily place both linear and curved junctions. One consideration to make is how this flange will split to be unfoldable. We have placed junctions, but this still needs to also have a split in the corner before it can be unfolded. For this, we have the smart split propagate function. As the name suggests, after one user click, we can define the location and it will smartly suggest where to direct the split. And not only that, it will also look for other locations to place the same split. In this case, we require it in all 4 corners, and now we have already split them all with the help of this tool. Now this part can already be unfolded. But as we do so, we can see there is an issue. The unfolding tool will automatically detect an issue with the unfolded part and highlight the relevant flanges with the issues in this red color. If we take a closer look, there is an intersection between these flanges. Now let us see how we can repair this. We can use the direct modeling tool push-pull to reduce the size of this flange. After we have done this, we can once more try to unfold the part to see if we have fixed it. And this time, indeed, there is no issue detected, meaning that the part is fully detailed and manufacturable. So now you can see that BricsCAD Mechanical allows its users to automatically detect the thin-walled solid as sheet metal, and even further can detail the design to make it more intelligent by adding sheet metal specific features, as well as getting the design closer to being manufacturable, just as easy as this. Now we will continue using the same methodology for the door so that we can also make it unfoldable and as a result manufacturable. Now all the necessary bends are done, and we can use the split function again as before. When working with sheet metal, it is important to keep in mind common manufacturing methods in this discipline. If we look at the door of our design, it has a lot of areas that could make this part difficult to manufacture. So with BricsCAD Mechanical, it is simple to just rework the sheet metal design. For example, by adding junctions, changing bends, adding splits as we have done so far. But we can also split this design into several members so that it can be cut out in separate parts and later added together. Here on the upper part of the door, there is some geometry that we need to solve. Currently, it cannot be unfolded with the rest of the door, as it would overlap and collision between these flanges would occur. So like I mentioned earlier, this indeed cannot be manufactured as it is, no matter how much information we apply. However, there are some occasions where it could work, but the unfolding would not be ideal in terms of saving material or saving space. So, like mentioned also before, we will split this part into several members so that it can more easily be manufactured and put together. After splitting this door into several parts, we now benefit from the ease of manufacturing it. However, it is a task later to assemble it again. So we can place a jog feature to add more support between these parts, but also to make it easier to position this in the right area when assembling it. So now we have separated the part successfully, and we have ensured to make it easy to assemble at a later stage. Next, we have this complex curved geometry. It does not make sense to make a bend out of this, so we will apply a junction here so that it will be split apart during the unfolding process. Now this complex curvature consists of several lines and several radii, but we can very simply select all of these lines with the selection window and simply apply the junction tool. And automatically it is defined in a realistic way so that it can be manufactured. So it is easy to select this complex curve and form a junction along it, but we still need to apply some manual steps to just make sure that the end split is placed in a logical sense. We still need to prepare the base of this cabinet also. As we can see, it is not shelled out yet, meaning that we cannot simply convert it to sheet metal as it does not consist of thin walls. So we could go through the tedious process of shelling it and applying sheet metal features, converting it, and so on. But we also have a more simple tool to help us with this. We can use the feature called SM Quick. This will allow us to simply select the base solid, select faces to remove, and immediately the tool will suggest a sheet metal layout with features on it so that we can only apply a few more tweaks to make it unfoldable, making it super easy for us to convert this to sheet metal. Now, as we have applied all the sheet metal intelligence, we can further benefit from this by unfolding all the parts and preparing them for manufacturing. We can continue using the unfold option for each solid, but we also have a tool to immediately analyze the entire assembly, find sheet metal parts, and create manufacturing-ready files. And it is as easy as this. Now we went from a simple 3D solid with no manufacturing intelligence to a fully manufacturable design, including all the files needed to manufacture it. We have easily generated this report, and as you can see, we have all the files needed for each individual part to be able to cut it out from a sheet of metal. As you have just seen, BricsCAD Mechanical offers a powerful sheet metal modeling toolset in the CAD platform, giving you the benefits of CAD and getting you ready to benefit from the actualized sheet metal components in your designs. Not only that, but BricsCAD also helps you supply fully manufacturable components ready to be made. So if you see value in this, please consider going to our website at bricsys.com to find and download a full BricsCAD trial to try this for yourself today. Thank you very much for your attention.